Next video I'd like to talk about the cast diagram and values of sine, cos and tan in our four quadrants. But let's just review what these four quadrants are. Remember, we've got the full circle here, 0 round to 360 degrees, so 0 round to 2 pi, round to here. And just remembering that I really want to use radians now, radian measure, instead of degrees. So I might mention degrees from time to time. We're going to do some problems in a little while with degrees, but I want to concentrate mainly on radians. So there's our circle. First quadrant, okay, is between 0 and 0 and pi on 2, or 90 degrees. So that's our first quadrant, from 0 round to there, to there. Our second quadrant is between pi on 2 and pi degrees, so round to there. Third quadrant between pi and 3 pi on 2, that's 180 and 270 degrees. And fourth quadrant from 3 pi on 2 round to 360 degrees. So there's our four quadrants. You might have seen something called the cast diagram before, and I'm going to show you this before we work through how we find sine, cos and tan in all the quadrants. But you might have seen this before, and it makes up the words cast from bottom right round to bottom left. So C, A, S, T. Now what does that mean? Well, it means that all the ratios, all the trig ratios in that first quadrant are positive. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant. And only cosine is positive in the fourth quadrant. So that's what our cast diagram means. Let's start by looking at the second quadrant. What I've drawn here is our unit circle that we visited when we started our unit here on circular functions, our trig unit. And remember we defined the point P there as cosine theta, sine theta. Now, if we go into the second quadrant, we'll see that length there of cosine theta, because it's going in a negative direction, okay, in this direction here. Just get a little arrow happening. Because we're in that direction here, the amount is still the same, cosine theta, but the sign is different. So it's negative cosine theta. It's in a negative direction. So that's why there we've got negative cosine theta. For this triangle over here, you can see this green triangle. You can see that our sine theta is still positive. It's still that length there. So hence, we've still got positive sine theta there. So when we go into this second quadrant, that green triangle, we've got cosine being negative and sine being positive. So we're looking at our angle here as 180 minus theta. Okay, so that's what that angle is with the black arrow there. That's pi minus theta. 180 degrees, or pi minus theta. Its coordinates are negative cos theta and sine theta. So in the second quadrant, cosine is negative, sine is positive. Now let's look in to the third quadrant. This time our angle is pi plus theta. Okay, so it's pi, which is around to here, plus theta. Here's our coordinates for pi plus theta, the blue triangle that I've drawn there. This time, if we look at our value of cosine theta, once again we're in a negative direction. Okay, so it's negative cosine theta. Our sine theta, our length this way, see that arrow there, is also negative. Okay, it's at the same magnitude as sine theta, but it's in a negative direction. So both cosine and sine are negative for the third quadrant. Hence you can see that point there, negative cosine, that point there, negative cosine theta, sine theta. So cosine and sine are both negative in third quadrant. Fourth quadrant, this time we've got this angle here, you can see with the black pen going all the way around. This is 2 pi minus theta, so 360, remember 2 pi is all the way around our circle, minus theta. This time our point, which is here, has got a positive value for cosine. Okay, you can see there. But our value for sine dips into the negative. So a negative value for sine. Hence the point there, over here, is cosine theta, comma, negative sine theta. So in fourth quadrant, cosine is positive and sine is negative. Now let's go back and review here, because I want to now talk about tan. So let's go back to the second quadrant stuff. Let's get rid of some of the boxes here. I pointed out that in second quadrant, cosine is negative, sine is positive. So what about tan? Well, we know that our formula for tan theta equals sine over cos, but this time we've got sine over negative cos over here, because cosine is negative. Therefore, if tan is defined as sine over cos, our value for cosine is negative. We've got positive over negative. Our tan value in second quadrant is negative. So there's our summary for second quadrant. There's what's called our second quadrant rules, and we'll be referring to those anytime we're looking at a second quadrant angle. Sine is positive, cosine is negative, tan is negative. Moving on to third quadrant. This time, sine and cosine are negative. So tan theta equals, remember tan is defined as sine over cos, so neg sine theta over neg cosine theta. So tan is sine over cos, they're both negative. Negative divided by negative is positive. So you can see here that tan in third quadrant is positive. And ladies and gentlemen, there are our third quadrant rules. Sine is negative, cosine is negative, tan is positive. Fourth quadrant. Let's have a look at tan here. Tan theta equals negative sine theta over cos theta. Negative over positive is negative, hence fourth quadrant we have negative tan theta. So our summary for fourth quadrant, sine is negative, cosine is positive, tan is negative. So that's how we get our cast diagram. They're all positive in the first quadrant. Sine is positive, hence cosine and tan are negative in the second quadrant. Tan is positive, hence cosine and sine are negative in the third quadrant. Cosine is positive, hence sine and tan are negative in the fourth quadrant. The next set of problems involve using the rules we just discussed and finding exact values. Now, exact values, just to store in your memory bank for this year, are either fractions, surds, that is square roots, or pi expressions. So when it asks to give the exact value, they have to be in fraction form, surd form, or with respect to pi, say pi on 4 or pi on 8 or something like that. So we're asked here to find the exact value of sine 120. So these will involve, if I just go back here a little bit, these will involve these 30 degree, 60 degree, or pi on 3, pi on 6 rules, or the pi on 4 rules. So let's look at this first one. It's sine 120. Okay, if we look at our circle here, where does 120 fall? Well, we've got pi on 2 there, or 90 degrees. Perhaps I'll use degrees this time, even though I prefer to use radians. So we've got 90 degrees there, and we've got 180 degrees there. So sine 120, or the degrees 120 there, clearly falls into the second quadrant. Now, as soon as I see that, I use my second quadrant rules. Remember, we've just developed sine, cos, and tan in other quadrants. Just digress for a moment. I'll put on this slide the 4 sets of rules. First quadrant, second quadrant, third quadrant, fourth quadrant. And you can see there that whichever quadrant our angle falls into, that's the set of rules that we'll rely on. Of course, first quadrant is just sine, cos, and tan as normal, but second, third, and fourth, we've got those rules that we've just developed. So back to our question. Okay, so because this is in second quadrant, see I've selected here the second quadrant rules. There they are there. And because we're using sine, I'm going to use the sine rule that is relevant to second quadrant. So that one there. So let's work through this problem. Okay, we've got sine 120. So I'm going to convert that, because it's second quadrant, to sine pi, or 180, minus a certain angle. Okay, now what angle do we subtract from 180? We subtract 60 from it. So it's 180 minus 60. So we put here equals sine 180 minus 60. Now according to our rule, sine, if I just please look at this blue square here, sine 180 minus an angle equals the same as the sine of that angle. So I can actually convert that to sine 60. Probably should put my degree signs in here. Okay, so what is sine 60? We can look it up in our table of values. Sine 60 is root 3 on 2. So sine 120 is root 3 on 2. So please just look at, if I just draw an arrow here between those two, you can see that sine 180 minus an angle is the same as the sine of that angle. Next question, sine 210. Let's look at what quadrant we're in. Remember, we've got 90 degrees here, we've got 180, and we've got 270. So we're looking here at this angle falling into the third quadrant. Hence, you can see I've already done this beforehand. I've dug out our third quadrant rules. It's a sine question once again, so I'm using this rule here in particular. Sine 180 plus an angle equals negative sine of that angle. Okay, so let's use that rule. Correct pen. Equals sine 180 pi plus 30, because 180 plus 30 gives 210. So that's the question we ask ourselves. Once we've seen it in third quadrant, okay, it's 180 plus an angle. What angle do we need? We need 30. According to our rule, that equals the same as negative sine 30. Okay, so sine 180 plus an angle equals negative sine of that angle. Equals sine 30 is a half equals negative a half. Answer, negative a half. Next question, sine 315. Okay, this time we're actually in the fourth quadrant, because remember it's 270 there, 360 there, 315 falls in that fourth quadrant. I've isolated our fourth quadrant rules, and the sine rule for fourth quadrant is this one here. Sine 360 minus an angle equals negative sine of that angle. So this time we're looking at sine, equals, get it right eventually, equals, okay, so we're looking for sine, what do we take away from 360 to get 315? Sine 360 minus 15. Minus 45, sorry. So our rule says down here that, just highlighted here, a sine 360 minus an angle equals negative sine of that angle. So we get equals negative sine 45 equals, remember sine 45 is root 2 on 2, negative root 2 on 2. Just on that, I'm getting all these values, remember, from here and also from here. So I'm not pulling them out, where we're not pulling them out randomly, where you can find them. Now, next one is cos 405. Now, this is an interesting one because remember our circle here stops at 360. Well, it doesn't really stop. That's what I want to talk about here. If you get beyond 360, you start going around a second time. So to get cosine 405, effectively, cosine 405 is going round once and going round again another 45 degrees. So really, we're here now. We've gone round once and we go round again another 45 degrees there. it's effectively the same as cosine 45 degrees equals square root of 2 on 2. Now I want to look at some problems with radians. Same method, but this time because we're dealing with radians, they're not quite as familiar, and working out what quadrant they're in is a bit trickier. So let's get our little circle going again here, and we know that we've got 0, pi on 2, pi, and 3 pi on 2. So our first angle here is sine 3 pi on 4, or 3/4 of pi if you like. So we've got half a pi here and a full pi here. 3/4 of a pi falls right in between. So we're in second quadrant. And I'm going to start writing this down now. Second quadrant. So I've got my second quadrant rules down here in the bottom right hand corner. And for second quadrant, sine 3 pi on 4 equals, sine pi minus something. Now, what do we take away from pi to get 3 pi on 4? Now, remembering that pi is actually 4 pi on 4. So what do we take away from that to give 3 pi on 4? Well, obviously, take away from 4 pi on 4, we take away 1 pi, or pi on 4, to give 3 pi on 4. So sine 3 pi on 4 is sine pi minus pi on 4. Now, our rule says here, highlighting it in blue, sine pi minus an angle equals the same as sine of that angle. So this is now effectively sine pi on 4, which equals, running out of room, so I'll do it here, root 2 on 2. And that's our answer for sine pi on 4. Sorry, that's our answer for sine 3 pi on 4. Next one is cosine 4 pi on 3. Let's look at our unit circle. We've got 0, pi on 2, pi, and 3 pi on 2. 4 pi on 3, 4/3 pi. Where's that going to fit? Okay, let's look at, remember 3 pi on 2. Look at this one here. If I convert that to pi on 6, that's going to be 9 pi on 6. Okay, and pi here is going to be 6 pi on 6. Pi on 2 is the same as 3 pi on 6. Okay, so sometimes with these pi on 3 ones, if you convert those key points to pi on 6, and I'll just highlight them, 3 pi on 6 there, 6 pi on 6 there, and 9 pi on 6 there, it's a bit easier to see. Because 4 pi on 3 is, okay, 4 pi on 3 equals 8 pi on 6. Okay, so you can see that that falls between, or in the third quadrant, between 6 pi on 6 and 9 pi on 6. So cosine 4 pi on 3, okay, is going to be cosine, because it's in third quadrant. We're looking at what are we adding to pi to get this angle. Pi plus pi on 3. Now, according to our rule, sorry, we're using cosine. Start again. According to our rule, cosine pi plus an angle equals negative cosine of that angle. So it's going to be negative cosine pi on 3. Cosine pi on 3 is a half, so our answer is negative a half. Sine 11 pi on 6. Here's our unit circle, oh, sorry, not our unit circle, our circle with the 4 quadrants. So we've got 0, pi on 2, pi and 3 pi on 2. Mentioned in the last unit circle, you can see in blue there, I've still got them. That's 3 pi on 6, 6 pi on 6, 9 pi on 6. And I'll move that a step further. Around 12 pi on 6, so square around that one as well. So this time we've got 11 pi on 6, so that's fourth quadrant. Okay? And fourth quadrant for sine. Here is the rule that we're using, fourth quadrant for sine. So this is going to equal sine 2 pi minus an angle. Now 2 pi is 12 pi on 6. Okay, I just showed you that. So we've got 12 pi on 6 minus something gives 11 pi on 6. And that something is pi on 6. Our rule says sine 2 pi minus the angle equals negative sine of that angle. So it's going to be negative sine pi on 6 equals negative sine 30, or negative sine 30, and that is negative a half. Here's another example of problem where we've gone around the circle once and we're going around a second time. I've drawn the circle there this time, and instead of pi on 2, pi, 3 pi on 2 and 2 pi, I've put everything over 4. So 2 pi on 4, 4 pi on 4, 6 pi on 4 and 8 pi on 4. Now 9 pi on 4 exceeds 8 pi on 4. In fact, we're going around another time. So this is the same as 8 pi on 4, or 2 pi plus another pi on 4. So we're going around a second time, so we're here. So effectively that's the same as cosine pi on 4, which is the same as root 2 on 2. Okay, long video on this one, but you should now be able to do exercise 6b, numbers 1 and 2. Good luck.